Do you want to add high power laser cutting to your 3D printer? Well, today I have a very honest review of a 10-watt endurance laser. So you've gotten a 3D printer and you love the fact that you can now make your own things, but maybe you want to expand your manufacturing capabilities and you've been eyeing off a laser. The best bang for your buck would be a cheap CO2 laser from eBay or similar. They're generally 40 watt, capable, but the machines need a lot of room. If this is your case, the only other option is a diode laser. They're small and compact, so much so that you can fit them to other machines such as CNC routers and 3D printers. I've covered a low power half watt Chinese add-on before, but today I have a 10 watt unit from Endurance Laser. It makes some pretty bold claims, so let's start by examining the product. Endurance Laser sells a range of different kits varying on power from 2.1 watt all the way up to 10 watt plus. The one we're doing is the standard 10 watt invincible continuous power. These sales are constantly running, but it is rated at around $600 US. It advertises that it's compatible with any 3D printer or CNC machine and to have outstanding customer support. We have a table of all of the things that it can do. I'm mainly interested in cutting, so I can see it can do leather in a single pass up to 3mm, cardboard and cardboard up to 4 and 5mm respectively in a single pass. I'm interested in cutting my recycled PLA sheets, so it should once again be able to do a single pass up to 5mm or even 8mm with 2 to 3 passes. Acrylic 3 to 5mm assuming it's dark in a single pass, and up to 5mm plywood with a single pass or 8mm with 4 to 8 passes. We see that the maximum cut is 10mm for wood and other soft materials. We have a range of 5-star testimonials, some technical information, and some diagrams showing the components that come with the kit. The core attributes that Endurance claims is to have high quality standard, ultra reliable, true continuous power output, unlike Chinese lasers, plug and play, return policy that's friendly, and a lot of emphasis on advice and professional support. Endurance Lasers has a big emphasis on these products being much better than Chinese copies. And in this video, they test side by side their own laser versus a Chinese cheaper version. You can see the exact same circular cut is taking place on each side. And when the job is finished, only the one from Endurance actually manages to cut through. This is advertised as reliable, honest, and the best you can get in diode lasers. Now the elephant in the room is price, but if it works as advertised, there's not really any other products in this form factor that can compete. This will be making its way onto my Lowrider 2 CNC, but for today I'm putting it on a 3D printer. You might be getting the impression that not everything went as planned, but to make this video as useful as possible, I'll still start with presenting a guide on setup as well as safety. Let's start with safety, and the most obvious hazard is the threat to your eyes. This kit comes with a set of green laser goggles, and I know from previous videos people are automatically going to say they're not up to the job. In terms of glasses safety, there's a really interesting video on the Endurance YouTube channel that compares different types back to back. At low power exposure, which you would expect when you're using the machine as usual and the laser's not shining directly into your eye, the green glasses did a good job. However, full power directly into the glasses for all of the glasses was nowhere near sufficient. This is a serious laser, and at all times you should have your glasses on before powering up the machine. Never ever, even with glasses, look directly into the laser. The next biggest hazard is fumes, and there's a really good safety page on the Endurance Lasers website. Some materials are not recommended at all. ABS plastic for one melts and produces cyanide, so I won't be using that at all. There's also a table for safe materials. And the term safe is always relative because there are still warnings for things that can catch on fire or produce excessive smoke. Before you use any material with a laser, make sure you do your homework with a page like this to make sure you're not putting your health in jeopardy. As well as a well ventilated room, I'm using a desktop smoke filter. At the moment it's dangling above, but on my Lowrider 2 CNC I'll be able to connect it properly. The other main hazard is risk of burning your hands. If this is powerful enough to cut clean through timber, it's definitely going to do some nasty work to your fingers. Make sure you keep them clear at all times. The kits come with a range of components, but it's only this actual laser module that needs to be mounted to your machine. I'm mounting onto the Tevo Tornado, and that is effectively the same mounting as a CR10. and I found this awesome quick change kit for that printer on Thingiverse. Only trouble was, it had mounting for a Chinese laser instead of the Endurance one. I then found this remix part to suit an Endurance laser and work with the other system. This design is inspired by a tripod quick release system, and I printed all of my parts in PETG. You can see we have a swivel arm up the top, and then the plates for the various tools slot into that and are retained when it's rotated. This one here is for the standard hot end of the printer, so you can continue to print when you're not using the laser module. Your first step in fitment is to remove everything from your standard hot end. Once this is done, we'll see that the plate is going to fit over the top of the existing bracket. We need to disassemble the 3 rollers that hold the plate to the extrusion. As you do so, pay attention to the order in which they come undone. They'll need to go back on the same way. The standard M5 bolts will no longer be long enough because of the thickness of the plastic. But apart from that, everything goes back together the exact same way. We're going to insert our nut into the printed part and start with the bottom bolt, before following with the left and right upper bolt to hold back on the carriage. Don't forget that as well as tensioning all of these, that you still need to adjust the eccentric nut to remove any wobble in the assembly. If you're using a standard hot end, you can simply bolt it on, but I was running a modification, which means I had to undo everything before I could access the mounting points I needed. After this, I could put everything back together, lock the top, and I could 3D print as usual. Just remember, with this slightly thicker spacer beneath the hot end, you will lose a little bit of printing area in the Y direction. Mounting the laser is super easy. We simply use 4 M3 bolts to go through the printed part and attach to the extrusion that holds the heatsink. After this, it goes in place the exact same way as the 3D printer hot end, locking in and becoming very secure. I found this quick release system and the remix were designed very well, as once I had it locked firmly in place, I had very little play. In terms of powering the laser, there's a power supply that comes with the Endurance kit to take care of that. The control box for the laser is 12 volts, but there's also these connectors, and that's because we also need to wire up the TTL input so the 3D printer can control the laser intensity. The Tornado has an MKS Gen L with spare servo outputs. These are ideal because I have 5 volt PWM. This signal is compatible with the laser, and we're going to use the ground and signal pins, in this case D6. I made a plug to match the diagram with a DuPont connector and then plugged it into my mainboard. You can see in the first servo slot I have a BL Touch in place, so I put it in the one next to it. Pretty hard to see here, so please refer to the previous diagram. Now we have the simple job of using the provided connectors to connect up the mainboard output to the TTL input of the control box. After a bit of soldering and heat shrinking, this was complete. We're going to tell our Marlin firmware that we're running a second fan, because that simplifies the G-code later on. That means we don't need to unplug the standard part cooling fan, and our G-code will be M106P1 and then S followed by a number for the laser intensity. To enable a second PWM controlled fan, so we don't need to scavenge from our main part cooling fan, we're going to come to this drop down menu here, and we're going to scroll down a long way until we get to pins ramps. Here it is, pins_ramps.h, the MKS Gen L that comes in the TiVo Tornado, like many other modern mainboards, is based on the ramps. What we need to do is to do Control F for search, and then search for fan 1. Now there's going to be a few instances of it here, so we're going to keep on searching until we get to the bottom of these. Here's the last one here, fan 1 pin, and at the moment it's set to MOSFET_D_pin, so we're going to change that to pin 6, which is the second servo slot. And that is it, that's the only change we need to make in the firmware. Everything is now wired up and ready to use. If you switch it to 1, it'll give you full power, and 2 will be TTL control from the 3D printer. If you're using the fancy control box, the right hand switch will go full power regardless of the left hand switch. Switching it to 1 will give you TTL control from the 3D printer, and switching it to 2 will give you control from the Arduino Nano contained within the box. The laser is installed and almost ready to use, so now we can turn our attention to setting up some free software as well as focusing the laser. For this guide, I'm going to use free software and I'm going to use Inkscape. It's linked in the description and is a free download. Endurance Lasers has their own plugin to make G-code from this, but I prefer this JTech Photonics one as it's easier to position your cut in the right place on your printer bed. Simply match up for your version of Inkscape and then download the plugin. After you've installed Inkscape, if you come into the Share folder, you'll see there's an extensions folder within that. we can open that and then unzip the contents of the plugin to put them here. One of the files that you unzip will be called laser.py, and I recommend opening that with the text editor and putting in the header and footer as you see here, and I've got this linked in the description. This means at the start of your laser job, it will home X and Y but not Z. It'll move Z up and down 0.1 of a millimeter just to energize the Z axis and to prevent any droop. And then at the end of the job, it will home X and Y again and return Z to the starting height. It might not be obvious at this stage, but using this combination of header and footer G-code will enable you to have variable Z height while you're cutting. Back in Inkscape, you can import some artwork or use the tools to draw your own. And when I'm testing, I like to have very simple shapes. With your shape selected, now come up to Extensions, Generate Laser G-code, and then JTech Photonics Laser Tool. Because we're using the second fan, we have M06P1 and M107P1 to turn the laser on and off, and then after that we have our laser speed and maximum power. We also have our amount of passes we want to do, and the reduction in depth for each pass if you're doing that. Apart from the output directory and file name, all we need to do is click Apply. After you've processed for the first time, you'll notice this graphic come up here, but don't delete it. This will tell you where your object will start relative to the front corner of the bed. Your toolpath will also be highlighted with these arrows to tell you the direction of the cut. And here's the resultant G-code file. It starts by turning off the laser, homing the machine, energizing the Z axis, and then follows the G-code to do our cut. At the end, it homes the machine and returns to the original starting height. Focusing the laser is the equivalent to nailing the first layer on 3D printing. It's crucial and it trips up a lot of first-time users. I was hoping Endurance would have a concise guide on their site, but instead they have a page full of many videos. For something so important, I wish they had a better resource in place. I therefore present to you my concise guide, and we start with the laser diode. It's actually quite small and hidden within the metal casing. That metal casing is simply a heatsink because the diode will get very hot. If we run the laser with this base configuration, we'll see that we can't actually cut anything, and that's because it's not focused. We can see here without the lens in place, the cutting spot is very wide and all of our power is dispersed and weak. Therefore, we need some coated glass lenses that screw onto the bottom and enable us to focus. The Endurance website has a very cryptic diagram that's meant to be used to tell the different types apart. The most common lens is a G3 or 3-element glass. It has a long silver body and the glass you can see inside goes the whole way from the top to the bottom. Next up we have a 2-element G2. It has a long gold body and the lens goes to the top, but when you look down the barrel to the inside you can see that that lens is quite short. Finally, the G7. This has a shorter gold body with the lens wider and at the top, and when we look down the barrel, once again, not extending very far. You can see how much shorter it is than the G2. You can also see a rubber washer halfway down the thread. So which one do you choose? Well, the best description I found is from the website linked in the description. A 3-element lens loses some power but has a tight spot and it's good for engraving. A G2 has the best power but needs the material very close to the tip, and a G7 is a nice compromise between the two. When we screw one of these lenses underneath, instead of the beam spreading out, it's now focused down to a point, and the point where it's the narrowest is the maximum power. By twisting the lens up and down, we can move that focal point up and down as well. There's an optimum focal length for each lens, seen here for the 3-element lens of 63 to 67mm from the aluminium housing to the surface. Therefore, start by changing your Z height to match this value. Firstly, I'd recommend finding and printing one of these focusing rings from Thingiverse. They go around the outside of the lens and make twisting it a lot easier. We focus with very low power, so on the LCD, go to Control, Temperature, Fan Speed 2 and set it to something like 3. The maximum is 255. We now focus onto the top surface that we're cutting until the point is as fine as possible. With timber like this, you'll notice that when you hit the sweet spot, even at low power, it starts to engrave the surface. Other people prefer to use a piece of anodized aluminium like you see here because it reflects less and it's much easier to see how small the focus dot is. Unfortunately, nothing like this comes with the kit. If you were to switch to full power now and put a piece of material there, you'll be able to see the full potential of the laser diode. The G7 lens should work the same way, but just as you get to the sweet spot, it runs out of thread and falls off. This is a known issue and the fix is to make up a little thread extension adapter. The G2 lens is focused using the same method, except the focal length is much smaller. We're talking 4 to 8 millimeters. With our laser focused, we finally have everything we need in place to do some test cutting. So the video up to this point should serve as a useful guide for anyone adding a laser to their 3D printer. But we'll now turn our attention to the performance and results of this endurance unit. My experience started badly because the bits you saw me filming earlier on had to be sent back to Russia. The smaller of my problems was that I was meant to have been sent a G2 lens, but I was sent a G3 instead. I had to make videos showing that the focal length was much more than 4 to 8 millimeters, but even so, this was never acknowledged. I ordered a G2 lens locally, and that moved me on to my next major problem. The laser wasn't performing anywhere near as well as it should have been. I rigged up all sorts of multimeters to prove the fact that it was only drawing 2.3 amps instead of the required 4.5. And frankly, opening up the box for the first time left me a little bit surprised at the quality of craftsmanship compared to the premium price of this model. Around this time, I turned to the Facebook community, and I have to thank all of the people who attempted to help me with my woes. I also have to thank a gentleman named Florian, who George asked to help me. Despite having no obligation to do so, he still put time and effort into solving the problem. Eventually, George acknowledged that the kit was defective and asked me to send it back to Russia. This did cost me $50 in postage, but at least I got the upgraded laser control box when he sent me a new kit. The readout on the new, fancier control box makes it much easier to set the voltage and current, which I did from George's video online, coming in way below the settings he recommended. So it was time to finally get cutting to test out the performance as rated on the website. As you saw before, the most efficient way to test cutting performance is to do a simple upside down V from the edge of the material. There's no point doing a half an hour cut job to find at the end that it hasn't cut the whole way through. After finding the right combination of passes, speed, and focus, I could achieve a clean cut through and then verify it by cutting a proper internal shape. Unfortunately, these results were few and far between. Most of my testing was done with optimum conditions, a G2 lens with a focal range between 4 and 8 mm and speed between 50 and 150 mm per minute. To be thorough, I also completed a range of testing with the G3 lens, which I'm familiar with from 2 other laser cutters. As well as plywood, I also tried some melted down recycled PLA as produced by my shredder. This wavelength of laser shines straight through clear acrylic, so I also tried some opaque black in 3mm thickness. So what of my results? Well, 2mm plywood wasn't really advertised, but I could cut it quite cleanly at a reasonable speed in just one pass. 3mm ply was much more challenging. This diode is claimed to cut at 400mm per minute plus for just one pass for thicker plywood, but I can only manage 2 passes at 150. My 4W emblazer could do 2 passes at much faster 260, and the 5W emblazer at work can match the speed but only needs 1 pass. 6mm plywood was advertised with 10 passes between 30 to 100mm per minute. I could only manage a partial cut after 20 passes and it was stupidly charred. 8mm is also within the max 10mm bounds given. With the same settings, it was also stupidly charged. I don't think these parts would ever be usable. Next was recycled PLA sheet, and it was claiming I should be able to cut through with 1 pass at 500mm per minute. The reality was 1/5 the speed and 3 passes to kind of get through. This one's tricky because it melts and rejoins, so I'm willing to give it the benefit of the doubt. Finally, opaque black acrylic, and it was promised I could do it in 1 pass at 350. The reality was it couldn't get through even at a much slower speed with 3 passes. Now these results are clearly far below what I was expecting. So let's play devil's advocate and try and find the root cause. Let's say I don't know what I'm doing and I can't focus the laser. Well, I did use the exact same technique with the emblazer 1 and 2 successfully, cutting the same material with greater ease. Maybe it's the wrong type of plywood. Well, the plywood that I'm using for these tests comes from the exact same piece that I used successfully on the emblazer 1 and 2. One common problem is insufficient power. My power supply is rated for 30 amps and holds a steady 12 volts on the input even when on full power. Speaking of full power, I upped the current from what was shipped to me by following an endurance laser video to reach the maximum potential. So maybe the laser diode is overheating and losing power. Well, the maximum rating is 60 degrees and I never saw it once go over 30 degrees Celsius. A lot of people might say that I need to use air assists, But remember, I achieved my great results on the Emblazer 1 and 2 without using air assist. There's nothing on the product page that says I need to be using it either, and besides, with the nozzle provided, it's too big to fit underneath the laser unit when it's focused to 4 to 8mm as the G2 lens is recommended. But all of that aside, let's assume all the problems are with me, but then refer back to the product page. Let's review our 4 to 5mm plywood cut with a single pass at a reasonable speed. If we scroll down immediately below to the independent results, we can see that nobody is getting anything near this. Remember, it was meant to be one pass at a speed of 400 plus. And when a user posts up that it's taking them 10 passes instead of 1 to get through 5mm plywood, Endurance replies telling them 5mm with 10 passes is not bad. If we dig a little bit more beneath the surface, we can see that our continuous power has an asterisk, and that's the maximum peak power output in impulse mode, and that's not even the mode that we're using when we follow their guides. Furthermore, the 8.5, 10 and 10 watt plus lasers actually use 7 watt rated diodes. Is this some sort of trick with the way the power is classified? I'm not sure, but I'm left with more questions than answers. What can I say? My experience has been extremely disappointing, and there's such a huge gulf between the performance as advertised on the website and what I was able to achieve. This was going to go onto my Lowrider 2 to make an enormous laser cutter capable of cutting out big sheets of plywood, but now I'm just not really sure what to do. If you have any experiences with this product or similar ones, please leave them in the comments below. Thank you so much for watching, and until next time, happy laser cutting on your 3D printer. G'day, it's Michael again. If you liked the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.